Thank you very much, Kyle. Has anybody been to Old Threshers yet? Wow, that's actually a very impressive number. Hopefully the rest of you all can make it out. I haven't been there myself, but I've heard nothing but good things about the place. So I'm going to be talking to you about the engine that our team has been working on at the National Museum of Industrial History in Bethlehem, Pennsylvania. This is an 8 million gallon a day snow steam-powered water pumping engine used at the York Water Company. Has anybody in this room seen this engine before? 1, 2, 3, 4.
We actually had a tour of the walk, and we saw it running, or was it the other one?
Say that again?
The SIA had a fall tour there. We visited that station. One of those engines was running. Was it that one?
Was it the bigger one or the smaller one?
Don't know, actually.
Okay, well hopefully somebody took some pictures or a video and we can figure it out pretty quick.
I took a picture.
Well,
Awesome.
The other one is over at the Thresherman's site. Pinchers,
Not anymore.
oh, is that the one you got?
Yep, that's the one we have.
Oh, okay, I didn't know they had got there. I guess because they couldn't get it up and running.
That's right.
They didn't have the resources.
So yeah, so it's great to hear that some of you remember this thing back when it was in York. So you'll notice some changes that have occurred in the years since then, but this is really the story of how it got to Bethlehem. It's not something that you would expect. I don't think you ever expected that to happen at that tour back then, did you, Jerry?
No.
So we felt this was a very compelling story that had to be told. We also wrote a booklet about it. We have those for sale for $15 each. I cannot make change, but if anybody's interested, we have those available up here. But the story of the engine itself goes back to 1913. That's when the York Water Company awarded a contract to the Snow Steam Pump Works of Buffalo to build an 8 million gallon a day pumping engine. They said it could be steam or electric. They didn't care. They wanted whatever was cheapest. As you'll hear again, they were frugal York County Dutchmen and proud of that. So they wanted to get the most bang for their buck. So they put the engine into what was known as Grillhart Station. It was a pumping plant and is still active about 2 miles outside of York. The water company is the oldest investor-owned utility in the country, dates back to 1816. Began by pumping spring water, and then eventually pumping out of Cordoris Creek. But guess what popped up next to their pumping station? A paper mill. So they commissioned a study from a hydraulic engineer in Baltimore. He said in 15 years, you're not going to be able to pump any water out of this creek because it'll be so polluted. So right on schedule or so, they opened up a brand new pumping station 2 miles outside of town where they had fresh water. It was also along the northern and central branch of the Pennsylvania Railroad, so I could get my 2 minutes cold delivered into the pump house. And these were the actual pumps that they were using in 1897. A pair of Worthington triple expansion pumps. But these aren't triple expansion like most of us think about triple expansion. You're probably envisioning a marine engine standing vertically, or a traditional waterworks engine with flywheels. But before those became popular, triple expansion meant you had a duplex pump with 6 steam cylinders on it, 3 on either side. These were connected with cordless valve gear. So to pump 10 million gallons of water a day, you had a dozen cylinders with cordless valve gear on it, which was just effective. It worked, but when they figured out they could do the same job, a slightly smaller amount of pumping with only 2 cylinders, and they had to expand the pump house anyways, that's when they invested in the pumping engine that is now at Bethlehem. This is an exterior view of the pump house. On the right is the boiler house and smokestack. You can definitely tell that they're burning by 2 minutes cold in that photograph. On the left is the pump house. And this is probably pretty much what you guys saw in the SIA tour. I'm not sure if you might even recognize some of the people in these pictures. If you do, please speak up. This is a photo by Conrad Milster. He traveled from New York to see the engine. And this is what it looked like in the 1970s, early 1980s. The engine ran on daily service from 1914 to 1956. Then they put it on standby service. The insurance company wanted them to run it 2 weeks a year to prove it was a reliable backup operation. And you'll hear about this again in another presentation. That was the one of the ways that these engines kept on going much longer than they normally would have. So they ran it those 2 weeks a year, and they would invite steam enthusiasts down, clubs like the SIA to visit them, because even in the 1970s and 80s, these things were monumental. They were very impressive, just as they are today, and people wanted to see them. The water company also used them for situations like brownouts, where they would agree with the power company that, yeah, we'll shut the power off and we'll go back to steam for a little while. Or the famous event, 1972, was Hurricane Agnes. It flooded central Pennsylvania. The pump house was under 8 feet of water. The electric pumps were knocked out. They figured it would take 5 to 7 days to get them running. But after the waters receded, only a day or two to fire up the boilers and get the steam engines going again. So they got the steam engines running right as the water in the reservoir was swirling like water in a toilet bowl, about an hour away from running out. Water company said the first thing that happens when people are told to conserve water is they start hoarding it, so it makes the reservoirs drain even faster. So you can see that the engine this period has what I would call a battleship grade paint scheme. I'm not sure if you guys would describe it as such, but that's what it looks like to my eyes. For this view of the magnificent coreless valve gear. Now, in 1981, the boilers needed significant repairs, about $30,000 or so worth. So the water company did the math, and they figured out if they repaired the boilers and ran the steam engines regularly after that, they wouldn't have enough pumping capacity to meet the new demands of the company, because the New York area kept on growing and growing. So they decided it was more economical to replace the steam engines and boilers with a 20 million gallon a day diesel-powered pumping engine. So at that point in time, the engine that's in Bethlehem was donated to the Rough and Tumble Engineers Historical Association in Lancaster County. They moved it out of the pump house. In the process, they dropped the high-pressure cylinder. So you'll see later on what that meant for us. But they got the engine there, put it on the foundation that was misparred, and they started repainting it, got into a fresh coated primer, got the flywheel together, but they never finished restoring the engine. In the meantime, the sister engine, because there are actually, as you guys will remember, 2 of these things in the pump house, the water company said, well, we only need 1 engine removed to make way for the diesel, so we'll leave the second one in there. The second one, which was built in 1925, was designated ASME, American Society of Mechanical Engineers, Mechanical Engineering Landmark. They repainted it to its original color scheme, and the water company proudly shows it off to visitors who come to the pump house. Now, one little tidbit of history is this engine has Worthington on the side of it, but it looks an awful lot like our engine. That's because Snow pioneered this design, and Worthington actually acquired Snow. The water company found this out the hard way, because in 1914 and 1915, when they were corresponding with the Snow Steam Pump Works, records that the water company gave to us revealed that there was a $6.53 bill that Snow did not pay to one of the subcontractors. So the water company and the manufacturer were disputing who should pay this. It obviously should have been Snow, but they were in voluntary receivership. So eventually the bill went to the estate of the Snow Steam Pump Works, and Snow Steam Pump Works then got folded into Worthington, which was part of the amalgamation of the International Steam Pump Company that actually owned Snow. So in one way or another, all of these pumps are related, even those 1897 ones that we saw. The family tree of Worthington is really incredible if you get a chance to look at it. So the water company also put a little display up showing what it looks like inside the pump end. So they have hundreds of these rubber discs that raise up against the brass spring and washer. The water recedes down on them. Another gush of water comes in, and eventually it gets pumped up about 300 feet to a reservoir on top of the mountain, and then gravity feeds down to the city of York and 100,000 customers below. So in 2009, we were offered the engine by Rough and Tumble, and we were wondering what replaced the engine. We went to the pump house, saw the original engine house is still there, found the 1925 engine, the 20 million gallon a day diesel pumping engine, and we went down in the basement. Above grade, the foundation was leveled off, but below grade, it's still there. And one lesson we learned is that if you're ever offered free tools, take them when you're offered them. Don't say you're going to come back later. And you'll know why I said this when you see what we did to a later wrench. So this is the engine as we found it at Rough and Tumble. That's Rick Rowlands of the Todd Engine Foundation walking on top of the engine. He was offered the engine by Rough and Tumble in 2008 because he had moved and began restoration on a 260-ton rolling mill steam engine in Ohio. So they thought a 115-ton steam engine would be a small project for him. He said it was still more than he could handle at the time and suggested we go after it. So we looked at our collection, looked at our scope, what our mission was, determined it would fill some gaps in our collection, like we didn't have a water pumping engine, we didn't have a cross-compound engine, we didn't have a compound engine of any kind. So we figured this would be a great addition. Rough and Tumble was very easy to work with. Any other place, we would have to get all sorts of certifications to work in an active water pumping facility. Here, Rough and Tumble just called up some volunteers up the street. They took the roof off the building, and they let us haul the engine out piece by piece, and they even helped us, or try to help. In this case, this is a slug wrench that belonged to them. That's one of our volunteers on the left. They're a volunteer on the right. If you look real close, his foot is holding that slug wrench up against a giant nut about this much in diameter on the flywheel. So guess what happened when we both hit the wrench? Yep, the wrench broke. So we got a replacement wrench from another museum, got the engine apart, and hauled it up to Bethlehem. At this point, we knew we needed to save it because if we didn't rescue it, Rough and Tumble was going to cut it up for scrap metal, and probably would have got about $30,000 for it because scrap was high at the time. So it's really amazing that they had the generosity to save this and offer it at no cost to another nonprofit. It took 5 tractor trailers to move the engine up to Bethlehem. And then you can see how good our planning is. Does anybody recognize what this building is? Number 2 machine shop in Bethlehem. So we put a water pumping engine inside that building in 2009, took it out in 2015 to put it in the museum, and guess what they just made plans to put inside that building? A water park. So the engine stayed there for almost 6 years in storage while we figured out what to do with it. And again, back to our good planning, the engine was unloaded into a puddle here. So pay attention to what happened to that puddle a little bit later on. While we're figuring out what exactly to do with it, a lot of ideas were floated. One idea was to put it out front of the museum on a steel base, put an electric motor on it, just spin it around and make it look pretty. But one of our volunteers looked inside while we were unloading it and said, gee, this is really in excellent condition. It really shouldn't be outside, it should be indoors and you could run it again. So we kept that in the back of our mind. And then we were doing a planning project for the museum, trying to redo the displays and figure out what we should actually have in there. One of the designers said, you're already planning on having an exhibit about the 1876 Centennial in there. And he said, what was the big draw at the 1876 Centennial? And we answered the Corliss steam engine, but that was scrapped in 1910. So he said, do you have anything big like that? So I told him, yeah, we have a big Corliss steam engine from the York Water Company. It's only got a 14-foot flywheel instead of a 30-foot flywheel, but it's still big, it's still impressive, and realistically, we're never going to get a bigger piece than that donated to us that we could afford to move. So they said, even though it's out of the date range of the Centennial, it's still got that awe-inspiring factor that people can relate to, and let's put it in the museum. So after that happened, we had to start figuring out how do we actually do this. So we got in touch with Joe Michaels. He's a professional engineer in upstate New York. And he used to work for the Skinner Engine Company of Erie, Pennsylvania. And he had experience with them in South America, setting up engines in the jungle for sawmills, making electric power. So he still remembered this stuff like the back of his hand. So we talked to him. He told us how to design the foundation, gave us the general guidelines, like you want 5 times the mass of your reciprocating weight in concrete below the engine, figured out roughly how to lay it out, and was instrumental in designing a foundation that would allow us to run the engine at full speed. Cross sections of the foundation, and then the next step came, and this is about a year or 2 later, actually digging the foundation for it. This is inside the museum building, which is a former Bethlehem Steel electrical repair shop, 20,000 square feet. We have a second floor we'd like to develop in the future, and this was taken from an overhead crane looking down. So you can see they already started stubbing out utilities. Then we began digging the pit for the engine. The engine itself is 35 feet long. You can get a sense of scale because it's 20 feet between each column on the building. Of course, there's always surprises. Why there was a giant mass of concrete where we wanted to put the engine, nobody knows. It wasn't on any Bethlehem Steel blueprint. Nobody working there remembered it, but it was in the way, and the designers said not to tie it into the new foundation, keep it separate, so we busted that up. Then, of course, the soil wasn't up to par on some of the areas. We had to do soil testing to figure out how much load it can handle. So one area had to be dug out, filled in with stone, steamrolled, and repeated up until the foundation could rest on a solid surface. We had grant money used for the project, so all of the material used was American-made. The foundation here is 18 inches thick, rebar reinforced. Pouring the concrete for it, let it solidify. Then you can see the rebar rising again. There are two what they call inertia blocks, which is what the engine actually is bolted to. One on the left, one on the right, with the flywheel pit in the middle. And this is what the foundation looked like when we took the forms off. You'll notice there are no foundation bolts sticking out. This is because the engineer advised us to core drill them and epoxy them in later. And again, back to our good planning. The day that the move worked out to be happened to be the coldest day of the year so far, with a high of 18 degrees. The engine was literally frozen into those puddles that it sat in years earlier. You can also compare the pictures and see how much worse the roof got in the meantime. We don't own this building, so we have no control of what happens in there, but we're glad we got the engine out when we did. So one of the problems that we faced was how do you get a giant steam engine into a building that was never designed to handle it? The overhead crane in there was a 10-ton capacity, but we had parts that weighed up to 20 tons. Plus the crane had no electric power to it, which was an odd voltage that we'd have to get a rectifier for. So we put out bids for a rigging. The lowest bid came in from a company that borrowed a crane from their neighbor in Lancaster County. It's actually a double knuckle boom crane, imported from Europe 2 months earlier, and it usually was used to move concrete castings down near Lancaster. So it made the hour and a half minute trip up to Bethlehem and spent the day unloading the giant engine parts. You had to be very careful not to drive over the newly stubbed out utilities. And notice he's driving on gravel because the museum floor is only 6 inches thick in most places. That would be crushed by the weight of the crane truck plus the engine components. And even with all of the modern technology, they still had to drop and repick the big cylinder here. There it is moving into place, being aligned. The water pumps are coming in on the giant rollback. This is where my office is at today, and they just barely cleared the entryway. Unloading them. We also set the bottom half of the flywheel. The bottom half only. This is because we had to spend a day or two aligning the engine with piano wire and jacks before we put the upper half of the flywheel and crankshaft in a few days later. A lot of this work was done by Bill Hazard and Roger Kriebel. Has anybody here ever watched Jay Leno's Garage on YouTube and watched the episode about the walking beam steam engine Jay Leno has? It's a little brown engine with a walking beam on the top of it. That was moved by Bill Hazard. So he's got a lot of experience there. That rough and tumble, he set up a giant engine almost as big as ours that runs on propane and originally natural gas. So remember this thing here, that's the receiver tank. That's what holds the steam between the high pressure and low pressure cylinders. Again, dropping down onto the core holes. And only one piece of the engine was actually marked with the builder's name from a steel mill. This one was Jones and Laughlin from the Pittsburgh area. And those were used to hold the keys together, the pins that hold the flywheel together. These were heated up to about 500 degrees. Then they were keyed in, and the cooling shrunk the parts together much more tightly than they could be joined otherwise. And the crack there is intentional. It came that way from the factory, so it could be aligned perfectly when it was put back into the service. The floor was parted around the engine. Then it sat for several months while we put in the HVAC systems. And then we started working on the small parts. You can see one of our volunteers, Don Young. Some of you guys know him. He's seen here vacuuming out leaves that probably date to 1981 when the engine spent a winter outside before it was installed at Rough and Tumble. Then we had to get the engine physically moving so we could just install some of the parts. Things like the connecting rods only fit together in a certain position when you have to bring them into the engine. So we're seen here installing the pin, using a 10-ton porta-power to move the steam pistons, which had been soaking in penetrating oil. And then a lot of smaller work, like on the dash pots, cleaning them up, the bearings. Then we had a portable gantry donated by a board member to do the installation of the small parts, which weigh up to 3,000 pounds. Then we had a marathon 12-hour day with 20 volunteers painting the engine. And then it sat looking much like this for about the first year of the museum while we got open. And then we started looking at ways of getting the engine running. A lot of people said use the electric drive. When we looked into that, there's a lot of arguments for and against it. But what really tipped the balance for us was simply the cost of electric motor, the demand charges from the electric company, the friction wheel that would keep on messing up the paint on the flywheel, and general lack of maintenance that we see in other electrified engines scared us away from that. But we had Neil Cossins, former director of the Science Museum in London, visit and say, why don't you just run it on steam? He said, we do that in London, it's easy, it's never been an issue for us, it's not that expensive. And then 11 days later, visitors from Victaulic, they're a pipe coupling manufacturer near us, came by and said, we're introducing a brand new line of pipe couplings to join steam pipes together. You just use 2 bolts and they clamp together, and you move on to the next joint and keep on installing the piping. We're going to be getting a patent on it in about a year. This would be a great project to unveil it to the public on. So right there we had the idea that seemed was realistic in a museum setting. We had a supplier ready to donate material to us. So we said, let's go for it. And then we began the process of making the engine ready for steam. So we put new gaskets in it, got the tank underneath lined up. They had 7-inch pipe in a couple of places, so we had to have custom flanges wire jetted out to adapt to the 6-inch pipe. There were many piping pieces missing from Rough and Tumble. That's why all of the piping is pretty much brand new. Figured out areas where we had to make adjustments, like parts that were installed backwards during the cosmetic restoration. And then the pipe couplings began arriving. 3 pallet loads of them. And of course, we won an award in the process. And the pipe couplings went together literally over a period of a few days. Museum ran as normal, no disruptions, so we didn't have to put up welding curtains or smoke eaters. It was just a very, very smooth process. The company that installed the piping donated the services too, and there's their installer, very proud of his work. Then we borrowed a 1,200 cubic feet per minute air compressor from a local contractor, and then we ran the engine. But it made this horrendous knocking sound. It sounded like the engine was going to fall apart. But if you felt it, you didn't feel the vibration on it, only in very, very small areas. So we put a borescope in, thought maybe there was something wrong inside. Nothing. And eventually, one of our volunteers said, my air compressor makes the same noise on a smaller scale. Maybe there's a vacuum issue. So we started going into the historical literature, found an article from 1917 that said a condensing engine had some sort of issue with its condenser, which created a vacuum. And they made some adjustments to the exhaust valve because they were lifting up due to a vacuum in the cylinder. And we did a little simple test. We put